The ordinary objects you see, the stoplight, pedometers, airplanes, these all have something similar. Guess what? It's the application of calculus topic derivatives. But what is derivatives? Derivative is the function which gives the slope of a curve, that is the slope of the line tangent to a function. Maybe the definition is so quite confusing, so let me show you another example. This example is the most common example in derivatives, economics for an instance. In recent years, business analysts and economists have increasingly turned to mathematical methods due to the huge masses of statistical data, depending on hundreds or even thousands of different variables. Therefore, derivatives are useful in helping them analyze the changes in cost, revenue, and profit. There are three functions, which are cost function Cx, revenue function Rx, profit function Px. These functions Cx, Rx, and Px are often defined only for non-negative integers, that is for x equals to 0, 1, 2, 3, and so on. For cost function Cx is for cost of producing x units of the product. Derivative C prime x is called the marginal cost. Cx is always increasing with the x. Revenue functions Rx is a revenue generated by selling x units of the product. Derivative R prime x is called the marginal revenue. If x units of a product are sold at a price P per unit, the total revenue Rx is given by Rx equals to x times P, where P is the demand equation P equals to Fx. This revenue is the income generated from normal business operations. For profit function, Px equals to Rx minus Cx, where is the profit or loss generated by producing and selling x units of the product. Profit is the financial benefit realized when revenue generated from a business activity exceeds the expenses, costs, and taxes. Let me show you an example, which is maximizing profits. Suppose that the demand equation for a monopolist is P equals to 100 minus 0.01x, and the cost function is Cx equals to 50x plus 10,000. Find the value of x that maximizes the profit and determine the corresponding price and total profit for this level of production. Figure 9 is a demand curve. When the quantity is increasing, the price is decreasing with the function P equals to 100 minus 0.01x. For the solution, we must find the total revenue function is Rx equals to x times P, where x times 100 minus 0.01x equals to 100x minus 0.01x squared. Hence, the profit function is Px equals to Rx minus Cx, where is 100x minus 0.01x squared minus bracket 50x plus 10,000 equals to negative 0.01x squared plus 50x minus 10,000. The graph of this function is a parabola that opens downward in figure 10. Its highest point will be where the curve has zero slope, that is where the marginal profit P prime x is equal to 0. Now, P prime x is equals to negative 0.02x plus 50 equals to negative 0.02 in bracket x minus 2,500. So, Px is equals to 0 when x is 2,500. The profit for this level of production is P 2,500 equals to negative 0.01 bracket 2,500 square plus 50 bracket 2,500 minus 10,000 equals to $52,500. Finally, we return to the demand equation to find the highest price that can be charged per unit to sell all 2,500 units, where P equals to 100 minus 0.01 bracket 2,500 equals to 100 minus 25 equals to $75. Thus, to maximize the profit, To produce 2,500 units and sell them at $75 per unit, the profit will be $52,500. Do you know the role of mathematics in our daily life? We use mathematics in our business, where we calculate the production cost to determine product pricing, measure business profits, and also analyzing financial health. Or we can use math in our cooking and baking. We use it to measure and weigh the ingredients and to estimate the cooking or baking time. Math are also being used in exercising, where we measure the exercising time and counting the number of repetitions while exercising. We also use it when we are driving, where we are calculating the distance of the journey and for keeping track of the speed of the car to ensure safety. We also use math in our computer applications, where the concepts like computation, algorithms, and many more forms are the base for different computer applications. For other instance, we also use it in our construction purpose. We use it in calculations, preparations of budgets, setting targets, estimating the cost, and many more. We also use math in our planning a trip, where we prepare the budget for the trip, the number of the days, the destinations, hotels, adjusting our other work accordingly, and many more. Thank you for watching.